Hello everyone, how is it going? I hope everything is fine. So today let's solve the problem symmetric tree from the Leetcode. The problem name is 101 symmetric tree. So given the tree of a binary tree, check whether it is a mirror of itself or not. That means we need to check if we cut down the binary tree into two halves, they must be equal if we place opposite to each other, right? That means it is something like if we place this cut in front of the mirror, it should be like this. If it is like that, that means we need to return true. If it is not like that, that means it's not symmetric, right? So we need to return false in such case. So if we test this test case, we need to these two are equal. So 3 and this are equal. So 4 and 4 are also equal. So this is a symmetric tree. But here when we go left, these are equal. So after going left from this pointer to right, they are not equal, so we need to return false. So it's false here. So this is going to be the explanation of these test cases. So we need to let's analyze how to solve this problem. So basically we need to check all the left edges first, all the right edges of this first, this subtree. Then we'll come back here and we need to come back here and need to perform the same for this one as well, right? So to solve this problem, we need to have two pointers. One will traverse this subtree and another will traverse this subtree. Okay, so let's name that pointers as first pointer will traverse this first subtree and the second pointer will traverse this second subtree. Okay, so we need to go left and we need to go right for this subtree. Okay, first will go here and the second will go here and checks whether the values of those nodes are equal or not. So those values are equal, right? So it will go, the first pointer will go left and the second pointer will go right? As it is symmetric, we need to check the edges only, right? This will be reflected here, right? It's not going to be here. Okay, this 3 will be reflected here only if we place the subtree in front of the mirror. Okay, it is something like that. If your right hand is here, that means your right hand will be present here only, right? So the first pointer will be here and the second pointer will be here and checks whether those values are equal or not. So they are equal, hence the first pointer will go its left and the second pointer will go its right. As they are going to be null, we'll return, right, because they are not values. So after returning, we need to check the right subtree as well for this one, right? Let's say we are here. After checking this one, we need to go right. So same thing here as well. After checking this right subtree, we need to go left, right? So whenever we encounter null, after checking the left subtree, we need to go to the right subtree for the first pointer. Whenever we encounter a null in the right subtree, we need, after traversing the right subtree, we need to go to the left subtree, right? So this is going to be the process. We need to have two pointers. Okay, so first, now let us make a function bool dfs. Let's make a dfs of our tree. It's going to take two pointers, right? One will traverse the left subtree and another will traverse the right subtree. Okay, let's make the pointers as first and the pointers as second. So first of all, we need to check whether the nodes are consisting of values or not, right? If without having the values, if we compare, it will give us a error, right? Because it doesn't have a value. So we need to check if any one of the node is null. Will return they should be equal. If both of them are equal, then we need to return false, right? So if they are not equal, we need to return false. So this is going to be the condition, it satisfies those conditions, right? So now we will be having three cases. The first case is we need to check the values inside those nodes are equal or not. So let's write it at b1 only. So first to val is equal to second to val. Okay, now we need to check for the left subtree as well, right? First to, for the left subtree we need to go left, comma, second to the second subtree, right subtree we need to go right. Okay, this should be a call, DFS call, right? We are doing the recursive call again, and again for the right subtree as well. That means not right subtree, after reaching null we need to go to the right. Here also after reaching null we need to go to the left subtree. Okay, same thing. Let's mark this one as v3. So for the first one, after we reach null we need to go to the right, instead of left we need to place right. Here instead of right we need to place left. Okay, so all these three conditions should be equal, right? All these three conditions should be satisfied. That means all of them should be true. b3, this is going to be solution. So one condition we need to check is if root is null we need to return true only, because if nothing is there then it is also going to be symmetric only, right? If now we need to call the DFS function, root to left, root to right, we need to return this one. Let's see if we have done any typos or not. Tree not start, tree not starts again, first which is equal to right. Okay, checking the values here. DFS is equal to DFS second to right, going to the left. I think everything is fine. Let's check if there is any error or what. Okay, okay, hope you understand the solution. I think if you know recursion then I think this would be pretty much fine to understand. So thank you for watching. I hope you understand the solution.